Okay, here is a brief overview of RhinoCam. So if you open up Rhino 5 and you don't have the CAM plugins activated, all you have to do is go into the RhinoCam toolbar, or drop-down menu rather, and open both of these browsers, the Machining Operations browser and the Machining Objects browser. Okay, so it should look something along these lines. And what we want to do here ultimately is pull in information that the shop has already compiled about the cut feeds and speeds that are particularly effective on the Techno machine and also on the Onsrud when we get that in back in the shop from being repaired. We're going to go into more detail what all this information is about. A little bit later we're going to talk about setting up stock so we can visualize it in this space and run simulations, but we'll wait for another video for that. I think it's best just now to start walking through how to bring information in. We'll start using it and I'll just describe some things along the way. I should add right now that you can actually set up your own milling paths from scratch. But we're not going to do that in this class. We're trying to take a lot of that challenge out of the process by having a knowledge base, but it also protects the equipment from being used in inappropriate ways. So first of all, if you've just opened up your system, we need to load the tools. I'm assuming you've already downloaded the knowledge base and you know where it is on your computer. Mine I have on the desktop. So I'm going to hover over these icons and I'm looking for the one that says Load Tool Library, and I'm in the Tools tab here in the Machining Objects window. It's going to ask me to look for it. I know it's on the desktop and it's Knowledge Base 5.0 and it's in Tooling, and I'm going to bring all the tools in, but if you knew exactly what you were milling, say foam for example, you could just bring in the tools that we typically use for foam. And so it brings in all of the bits that we've characterized for use with the machine. And we'll see these in person later. So this is the diameter, 1/16 of an inch. And this is the end profile. This is a ball end, and then I think we've got some flat ends as well. It also talks about the fluting. We'll talk about the fluting later, but basically it's how the spiral turns. If it turns up or turns down, it either pushes material into the work you're doing or pulls it out. And it's advantageous in different milling scenarios, one or the other. All right, so now we want to load the knowledge base. This is all the settings for the CNC, so the feeds and speeds, the clearances and all that, and initial depth of cut. Hovering again, loading knowledge base, clicking here. I know mine again is on the desktop, and I'm going to go in cut paths, and in here I'm going to choose the particular material I'm cutting into. So I'm going to cut into foam, open that up, and then it gives me all the tool paths that we've predefined for you in foam. We're going to talk very soon about the kinds of machining we can do. We can do this thing called 2.5 axis machining and also 3-axis machining. The simplest way to look at it is 2.5 axis is two-dimensional stuff. So it could be that you're cutting out a square. So you cut a square in one plane, and if it's a really thick square, you would bump the machine down a little bit and cut another square out in that plane. When you're working on each plane, it's a 2-axis thing. It's not a 3-axis thing. The half-axis is the fact that you're stepping down between each cut to get to the next level. 3-axis is just three-dimensional milling, which is very exciting, and we'll get to very, very soon. All right, so we've already gone through this before. In order to get this information over here, to set up our toolpaths, we just need to drag it, get in the habit of dragging the folder itself. We looked at engraving. I'm going to go ahead and pull over a profiling pass so we can look at that real quick together. The default tool comes in. Default feeds and speeds are programmed, same with the clearance geometry. Where this flower-like icon is, it's essentially places where we need to add or update information, or if something's changed with your model, and this will need to be reviewed. So we come in, let's see if we can define something real quick. Let's just draw a quick rectangle, and let's say I want to cut out a 3x3 square out of foam. I would come in, double click machining features, select the drive, or containment region. Hit enter when I'm done with that. Save. Then I could walk down. If I wanted to change the bit, I could. If I wanted to confirm feeds and speeds, I could. Same with the clearance geometry and parameters. This is where we saw we can change the cut levels. Now this is a brief introduction to 2.5 axis milling. So this is different from engraving. So right now the primary difference to keep in mind is that with engraving you mill on a line. So if you draw a line in Rhino and say instead of milling you want to draw it on the CNC, that pen is going to follow the exact line you have in Rhino. In this case, you can cut on the outside or the inside of the line. So with a closed curve like this, you can engrave on the line with engraving passes, but you can cut on the inside or outside with profiling. So this is important if you're trying to cut a hole in something and you want the dimensions of the hole to be particular, precise. You need to cut on the inside. If you're cutting out an object where you want to keep the positive, you want to mill on the outside. Cut levels, let's just say that this is our 2 inches of foam, which is about 1.9 inches. We usually leave a little bit at the bottom. I'm not going to change any of this. And advanced cut parameters, the only other thing here is that in order for the material not to fall out once we cut all the way through it, we usually leave these things called bridges. I'm going to just show it to you when I simulate this. I'm going to say generate. We'll take a look at it together. So you can see in the side view that there's this little tab that's left over. These are the bridges, and that just leaves enough material so that the object doesn't go flying away. And you can see here, now that we've generated this to cut on the outside of the square, the blue line, which is the line of the milling tip, it's on the outside of the geometry. Okay, so if we came back into parameters and changed that to inside and regenerated, you see the blue line comes on the inside. We still have the bridges, but it's just going to be in this case, it would be better for cutting holes. Okay, that's a brief introduction to the Machining Operations Browser and also the Machining Objects Browser. I'm trying to think here if there's anything else we need to see in this moment, and let's keep it there for now.